Alright, so here we are, the first video in the V-Block series. Here's our print. You can see it's a symmetrical V-Block. Right now I'm showing you, those are face milled surfaces, but pretend that they are saw cut surfaces. This is a part that a student had started, and then I'm taking over. So if that was a saw cut surface, I would not want to set it down in the vise or on parallels, because it's likely to not be perpendicular to any other surface. So I'm doing my first op here of a profile cut on that surface, and again, pretend it was saw cut, not previously face milled. That's a 1-inch diameter end mill, and it's an extended length, so it has plenty of length of cut. It was what was handy on the bench, so I just decided to use it. I wouldn't want to use one of our 5/8 end mills that you'll find, the extended length ones around the shop. I would prefer to use a more stout end mill like this one here. And this Summit mill is a 40 taper, so it can handle this. You know, two of our milling machines have that 40 taper spindle. It makes a big difference over the R8 taper. Anywho, so I'm just touching off right now, and if this was a saw cut, after I touched off, I would probably move the table in the x-axis 20 thousandths and see if I could get the surface to clean. Now, on this setup, it was actually really close to being square, so I might have only moved the table 10 thousandths. And I'm taking a conventional cut across right here, and then I'm going to do a spring pass back with a climb cut. So if there were to be any deflection, I'm hoping that the cutter would remove that. Also, you have to have a head on your milling machine that you know is trimmed in. So if you're at this point in your classes, you've been taught how to tram in a mill head and how to check a mill head. So it's up to you to make sure it's not knocked off from being perpendicular. So that's my surface. I can't tell if that's the surface I just cut or if that's one of the previously face milled surfaces. But I have switched over. No, that's the face I just cut with the profile cut. I have switched over now to a face mill because I can get the material off faster with a face mill cuts than I can doing profile cuts. Just because this is carbide cutter, so RPM goes up and feed rate goes up. So it's faster in every aspect. Now, this would be my 2-inch length. I'm going to mill it to 2.010, and on all these sizes, my 2 inches, my 1 3/4, I'm going 10 thousandths over, so 2-inch 10. And if I ended up at 2.012 or 2.008, I'm not that concerned, but I want to make my parts identical to each other, so I would be taking the same depth of cut on my second block if I were machining 2 blocks. But for this video purpose, I'm only machining 1 block because well, I just don't feel like spending the time on making 2 V blocks, and we have plenty of V blocks laying around the shop as is. So I've lowered the spindle down to the stop, pretty much like always. I've raised the knee, I've touched off, and now I'm just going to take a rather camera magnet stuck on the spindle, so I couldn't lift the spindle up and then run off the part quickly and then lower the spindle back down. So I learned a lesson. If I stick a GoPro mounted camera to the spindle, I can't move it. And that goes back to the beauty of using spindle stops, is you can run up away from them, make moves, take measurements, you can come back down. If you do it in a consistent manner and you don't have any debris between the surfaces, you will have a very, very repeatable result. So write down dimensions, markings on your part to keep track. Now I'm looking to cut a 1/4 inch total off of this face and the opposite face. So I'm gonna touch off here, and then I'm gonna raise the knee 1/8 of an inch. The first side, I always say the first side is free. If I raise the knee 125 or 115, it really doesn't matter, because we're gonna cut to the dimension when we get to the next side. So just touch, raise the knee, make the cut. This face mill has it doesn't have a square shouldered insert, which is wonderful, because now I create a thinner chip with a lead angle on my insert, so I can feed faster and at a deeper cut and not have it be is high impact, and it's just a more pleasant user experience. So that's the beauty of a good lead angle on your insert geometry compared to a square shouldered end mill, which we do have those or face mill, which we do have as well. But you know, I'm opting to use this one because if I'm going to go all the way across a surface, I want to have a lead angle. So that's an 1/8 inch cut. You know, surface feet per minute for carbide. And the chip load, I wish I had wrote it down, but I'm gonna guess probably about 3 thousandths per tooth. I usually don't push it very hard in these knee mills. Now, if this was a bigger 50 taper machine where the head wasn't a universal head and it didn't tilt, then I would start to really let the metal have it. So there's the first side I cut. I'm gonna cut an opposite set of faces at my current setting, my current depth setting. So to go over what that is now that last side I just cut is now 1 7/8 across. I still have one surface that's 2 inches across, and that's the surface I'm going to cut right now, and then that's going to bring it to 1.875. So I made 0 adjustments, and you would do this with both blocks simultaneously if you were doing your project, because you're making 2 blocks. So what we're doing is we're getting rid of multiple adjustments, multiple measurements, and we're mass producing at a quantity of 2, which I know isn't really a mass production. But big picture, always be thinking, you know, making all your moves count in the shop. So there I am, 1.875. And the other surface now is 1.875, and I have my 2-inch 10 direction marked as well, because it's possible to take a block, especially if you're handling multiple blocks, and load one the wrong way, and then you start a cut, and pretty much when you start a cut, you've committed, and you can make scrap really quick. So a marker, making some notes on your parts can save you from that kind of error. Now, I have an 1/8 inch to remove, and I'm not, in the interest of making consistent parts, which is what I'm trying to show you how to do, I'm going to pull a 1/16 depth of cut. Then I'm going to inspect it, measure my part, and then I'm going to dial the remaining. And I'm going to aim for 1.760. Now, that 1.760, like I said, on this one I think I get 1.761 and about 5/10, which that's a caliper reading, so you know, take that with a grain of salt. But then the beauty is, on the next surfaces, I can do the same thing. I raise the spindle away from my stop about a 1/16, and I make a cut, and then I drop my spindle back down to my stop, and I make a cut, And then you'll see at the very end when I check my part that I end up within, by calipers, a half a thousandths or 1/1000th of accuracy compared to my cuts I'm making right now. Those chip shields, those are your friends. We have lots of them. Use them. When I used to be working, a lot of times I would use pieces of cardboard, blocks of wood, anything as a barrier between my hands primarily and the cutter's chips, and also your face as well, especially if you're not wearing a face mask like I was during the filming of this video. So that's after my adjustment. So I go ahead, I pop up the spindle, I move the table. On some of all these cuts, I'm blowing away the chips before I open the vise. Get in the habit of doing that, or brush them away, or do whatever you're going to do. But I pop this out and I take a measurement for the camera. And you see those big old burrs? That's one thing I left out of this video, is after every one of these cuts, when my part comes out of the vise, you have to deburr it perfectly every time, and you have to make sure your setup is clean every time. So 2 directions, I'm finished, and yeah, I write down 1.760, even though it was 761. I'm just writing down the number, the whole number. I guess I rounded. It's not that critical, but you want to make your parts at the same time, meaning simultaneously, cut after cut, so you end up with very close. So right there I'm pointing that I'm 59 thousandths above the spindle stop, and then I'm also showing you that if I didn't have a readout on the Z, which most of our machines don't, I could just hold up a ruler and see, oh, okay, I got about a 1/16 of distance from my stop to my little adjustment nut, and then make the cut. In a lot of ways, I actually would prefer this machine, these Summit mills, to not have the readout on the Z, on the spindle. When I learned how to machine, the mills that I used did not have that, so I find it to be in the way and kind of unnecessary, based off the skills that I developed. And these clips, I've been starting the cut and then jumping the, increasing the footage 300%, the playback speed. Now all I do, run my spindle down to the stop, and you can see it's within 0.0002. That's 2/10,000ths. That's perfect. I make my cut. I'm going to show you what I got. So yeah, I know this video, it's kind of boring, but getting your steps in the correct order and doing both parts simultaneously, it's going to make the difference between you either having a good results and making good time on this project, or struggling unnecessarily. And when you see this measurement here, it did not affect my emotions negatively. I was 1/762, okay, that's fine. If I had another block and I ran this same cut sequence again, they would probably all be within 1/1000ths, and that would be perfect for grinding. So, and also the cutting the slots. All right, we'll do that in the next video. Have a good day.